On 10-2? Okay, let's look at, what number was it?
17, 19, 21. But then I went to 23, 25, and 27 and used it.
Yeah.
Right?
For 17, is this the number 17 you guys have?
17 on the last one?
On 10-2.
Yes.
Okay. Is that what you're talking about? 17, this has to do with angle measurements. It doesn't have anything to do with. Is that the same one? You don't have your book, but okay. So let's look at. I think I know what you're talking about because there are some where they give you. Wait, yeah, 10-2. Is it 10-2 or 10-1? No, not 10-1.
You only use the theorem to find the
Side, not the angles. So classifying the triangles. You would use Pythagorean theorem on numbers 23 through 28. Yeah. So 17 would be the sum of a triangle is 180 degrees. So to find the missing measurement, you take 180 minus 60 minus 50.
And 19 would be 90.
Yes. So it'd be 180 minus 90 minus 41 1/3. To find this angle measurement, which 38 2/3. So yeah, Pythagorean theorem only has to do with sides, and you can use it to find, given a right triangle, if you're given two of the three sides, either a leg and a hypotenuse or two legs, you can find the missing side by plugging that in. Any other questions on the homework? 10-1 or 10-2?
Number 33.
33? Okay.
How do you know when you're setting them out like fractions to equal each other?
Mm-hmm.
How do you know which one is the first? Which one
It doesn't matter as long as you're consistent with your top and your bottom. So here, if I wanted to put the little triangle first, I could say 10 is to x plus 6 as, yes. And if I look at that and say, I don't know, maybe it would be better to have 18/6, I could write this as x plus 6 over 10 equals 18/6.
It really doesn't matter how you write it?
Does not matter. The whole thing with ratios is as long as you're consistent. Small is to big, as big is to small. I can say I'm going to take my small, multiply that by 2 to get my big, or I'm going to take my big and multiply that by half and get my small. So as long as you stay consistent with your ratio, you're perfectly fine.
And then cross multiply, back divide.
Yes. So if I look at this one, I take these two numbers, multiply them together, and I take these two numbers and multiply them together and set them equal to each other. So I would have 6 times x plus 6 equals 18 times 10. Or I'd have 18 times 10 equals 6 times x plus 6.
So you're cross multiplying both sides?
Well, because if I wanted to solve just for this, I would take 10 times 18 divided by 6. Right. And I could do that enough easy here if I just divide both sides by 6. I solve for x plus 6. And then to go ahead and solve for x, I'm going to subtract 6 from both sides.
All right, I got confused there.
So the cross multiply and divide is to find a missing ratio. right? So if I want to find this missing spot down here, I'm going to take 10 times 18, get rid of my highlighting here, 10 times 18 divided by 6. Set that equal to x plus 6 equals 10 times 18 divided by 6. So you see, I set this whole box equal to that. I cross multiply and divide.
That's what I did.
I put this box here.
And the answer didn't match.
So what do we end up here? X plus 6 equals 180 over 6. 6 will go into 180. 30 times. So I have x plus 6 equals 30. So if I subtract 6 from both sides, I have x equals 24.
That's the answer that I got.
Yeah, that's what x is. But this side would be 30. This side length is 30, but the x, what you're looking for, is 24.
Man.
So I think you're pretty close to getting it. You weren't solving for x, you were solving for the side length. The ratio is the side length. The ratio is saying this side length to this side length equals this side length to this side length, or over this side length. So I solved for the side length, which was about 30, but I have to then do algebra to solve for x. So x is 24. There's a couple like that where you go ahead and solve for the side length, and then the one extra step is to solve for x. Here, the side length is x. So if you solve for x, you did solve for the side length. Most of them, the side length is x. There's just a couple where the side length is not x. You have to go ahead and then set that equal to the formula and solve for x.
Okay. I think I got that.
Just one extra step there.
Yeah.
Because a lot of these basic concepts are pretty simple, but we're going to start layering some other type of math, like algebra, on it to go ahead and solve for the missing variable. Any other questions on 10.1 or 10.2? Today we're going to discuss 10.3. And 10.3, there's a lot of kind of definitions, what it means to be a polygon, and then classification of polygons, and then using that to find the angle measurements of a regular polygon or the side lengths of a regular polygon is given, and you want to find the perimeter. So we're going to look at, find the sum of the angle measurements in a polygon. We've already talked about triangles, adding up to 180 degrees. Turns out a quadrilateral, which is a four-sided figure, adds up to 360. So we're going to come up with a formula for any n-sided shape. So if I say your shape has 17 sides and you want to know the sum of the angles, you're going to be able to find that in a formula. And then you'll be able to find the sum of all the angles, and you'll have, in a regular polygon, meaning the sides are the same shape, you'll be able to find the angle measure of every given angle. They'll all be the same because it's a regular polygon. And then the last thing we'll do is find the perimeter, which add up all the sides. Polygon is the general term for a closed geometric figure whose sides are line segments. So it classifies everything but circles in a sense there. Two-dimensional. And they're classified according to the number of sides. So here's an example of the hierarchy of some polygons from 3 to 10 sides. We have a triangle. Any three-sided shape is a triangle. A regular triangle would be an equilateral triangle where all the sides have the same measurement, right? Quadrilateral, a four-sided shape is a quadrilateral. A regular quadrilateral would be a square, right? Pentagon, pentagon, five-sided shape. Hexagon, heptagon, octagon, nonagon, and decagon. So you'll be expected to know these 8 names. If it's anything above 10, they'll say a 17-sided figure or a 10-sided figure. But they might say an octagon, and you need to know that's 8 sides. Or heptagon, you know that's 7 sides.
You know these from tests.
Yeah. Right. And that's on your guys' handout. Oops. So it turns out the sum of the angle measurement in any insighted figure is going to be given by this formula. So you can see if I have a triangle, right? If I have a triangle, if n is 3, I plug this in, I have 3 minus 2 times 180, and I get 180, which makes sense, right? Triangle, the angles are going to add up to 180 degrees. If n is 4, I have 4 minus 2 times 180, and I get 360 degrees. So any four-sided shape is going to have the angle, the 4 angles are going to sum up to 360 degrees. So here's an application problem. Find the sum of the measurement of the angle of a heptagon. So we need to know a heptagon is 7 sides. So here n is 7. Use the formula n minus 2 times 180. 7 minus 2 times 180. So 5 times 180, which ends up with 900. (900 degrees). So if I add up the angles in a 7-sided figure, they're going to add up to 900 degrees. Yeah, I see how you apply that formula. It should be relatively easy to remember because you know a triangle has 180 degrees, right? So n minus 2 times 180. So if n is 3, you have 180, right? Quadrilaterals. Again, triangles, we've already kind of talked about classifying triangles. We have equilateral triangles, we have isosceles triangles, we have right triangles, we have acute triangles, we have all these different names for special triangles. Quadrilaterals are kind of in the same category. There's a lot of different quadrilaterals. A trapezoid is a quadrilateral that is exactly 2 parallel sides. And I'm going to show you a hierarchy of these in a kind of a tree table. Parallelogram is a quadrilateral with opposite sides are parallel and equal in measurement. So a parallelogram is a quadrilateral where the opposite sides have the same length and they're parallel to each other. A rectangle is a parallelogram with 4 right angles. So it has to meet the criteria of a parallelogram. The opposite sides have to have the same length. They have to be parallel. On top of that, if the angle measurements are 90 degrees, it's a rectangle. A rhombus is a parallelogram which all sides are in equal length. So a parallelogram, 2 pair of parallel sides. If they all 4 have the same length, it's a rhombus. If they all 4 have the same length and the angle measurement is 90 degrees each, then we have a square. And a square is a regular quadrilateral, right? So we have this kind of little hierarchy here where all 4-sided shapes are classified as quadrilaterals. Then you either have a trapezoid or you have a parallelogram. The trapezoid only has 1 pair of parallel lines. You have 2 pair of parallel lines or parallelogram. From parallelogram, you're either a rhombus or a rectangle. The rectangle is 90 degrees. So 2 pair of parallel lines, rhombus, they are all the same size, all the same length, but the angles aren't the same. And a rectangle, they're not the same length, but their angles are 90 degrees. And then you have a square. All squares are also rhombuses, rectangles, parallelograms, and quadrilaterals. Square is the most defined or kind of Not broad. It's the opposite of broad. Specialized quadrilateral. It has to have two pair of parallel lines. They have to be the same side. They have to be the same size, and they have to have the angles of 90 degrees. Two pair of parallel lines that have the same side length is just a rhombus. Knowing that it's 90 degrees tells you it's a square. Two pair of parallel lines is a parallelogram. A rectangle is when they have 90 degrees, but their side lengths might not be the same. So this is just kind of technicalities and classifications. If I say you have a rectangle, you know the sides aren't the same length. Every square is also a rectangle in a sense.
But not all rectangles are squares.
Yeah, not all rectangles are squares.
That's where it gets in.
Yeah, when you get questions like that. Rhombus, rectangles, squares are all parallelograms, and all parallelograms are quadrilaterals. We really don't do much with this hierarchy. It comes up in some exams to know the difference. Just basic kind of IQ test or, basic Mogia type stuff that they might throw in there. You see this with, like, even in the English section, they'll say a square is to a rectangle as an elephant is to blank, and then you have to fill in horse, cat, dog, things like that. So knowing these kind of relationships can come up that way. Getting to regular polygons have the same side length and the same angle measurement. So regular means that everything has the same side length and angle measurement. Most common example of regular polygons are squares and equilateral triangles, right? A square is a regular quadrilateral. Equilateral triangle is a regular triangle. So we can find the measure of each angle of a regular hexagon. So how many sides does a hexagon have? 6, right? So 6, I could find the sum of them, right? The sum of all the angles is going to be 6 minus 2 times 180, which would be, 720? 720 degrees. If I know I add up 6 things and it's 720 degrees, how much is each angle? So the formula here is n minus 2 times 180 divided by n. So I get the angle measurement of each angle is 120 degrees. This comes in handy when you go to drafting, or if you had to draw a regular hexagon and you have a protractor, you need to know, okay, if I start with 5 inches, I need to find what angle measurement I need here to make my next 5 inches. And what angle measurement do I need here to make my next 5 inches to get a regular 6-sided figure, right?
Why is it 2? Like minus 2.
Triangle is kind of the base of 180 degrees. We know that's a straight edge. So it has 3 sides. So if you take away 2, you get 180.
Oh, got it.
The last thing we kind of touch on is perimeter, which is pretty basic, especially if you are given a regular figure. So for a square, you're going to add up the 4 sides. You can also take 4 times x. Put in your calculator s plus s plus s plus s, or 4 times s. A triangle, you can take a plus b plus c, or 3 times a if it's a equilateral. Rectangle, you would take L plus W plus L plus W, which would be 2L plus 2W. Right, you guys know these formulas? Some of the students always kind of ask at the end of chapter 10 if they get a formula sheet. The formula sheet you will get, I'll be giving you, is the exact one you get for the Mogia. So whatever they feel you don't have to memorize, I'm fine with. So you can see they give you slope of line, equation of line. You might not use that for this test, but I'll just give you this. Area of a rectangle, perimeter of a rectangle is given there. So you'll need to know how to apply it, and eventually we'll talk about circles. But I'll give you this exact formula sheet. I'll also post it on Blackboard so you have it to look at before we go to take the exam. So let's look at this example. Finding the perimeter of a rectangle, the Hauser family finds their dream home perfect in every way except one. The backyard is not fenced in. Their dog lunch means room to run, roam. The rectangular portion of the plan to enclose is 95 feet wide by 70 feet long. How much fence will they need to enclose a yard for all four sides? Pretty long-winded question for a very basic setup. So we want to know how many feet of fence do I need to buy to have a 95 feet wide and 70 feet long backyard. So if I can draw that picture in there, what would my perimeter be? 70 plus 95 plus 70 plus 95, or you can use the formula 2 times 70 plus 2 times 95. What would this be? 95. 1. Sorry. Nope. Why can't I do basic math? Thank you. So add those together, we get 330 feet.
Can we just put FT?
You can put FT, that's fine. And eventually we're going to talk about conversions. So if I have feet or feet squared, things like that, how to convert. If I said, 95 inches by so many feet, I would need to get that in the same units. We don't do a ton of that, but we will go over it. So there is something to consider what your units is. Yeah, we'll do both, yeah. Any questions on that? Right, so you kind of feel like a little bit going back to middle school. The length of each side of the wall, the pentagon, is 921 feet. So suppose, can't read. I don't know if that's supposed to be security, must walk outside a wall. Sentry must walk outside a wall 6 times during his 4-hour shift. How many miles does he walk in one shift? This is an example when they give it to you in feet, want your answer in miles. There are 5,280 feet in a mile.
We need to know small stuff like that.
If it comes up, I'll give it to you. But some things are pretty basic, like 12 inches in a foot, 3 feet in a yard, 5,280 feet in a mile. So I need to find the perimeter of walking around one time and then multiply that by 6. So the pentagon has how many sides? 5, right? So 5 times 921 gives me how many feet he walked for one time around?
4,105.
4,105 feet.
Tell me if I'm wrong, because I did that. with my
No,
head now.
4,600.
4,600? 4,600?
Yeah, 605.
Okay, I was like, 5 feet. 4,605 feet. That's one time around. So then if I multiply that by 6, what do I get?
27, 650.
So we 1,630 feet, which is kind of hard to kind of translate how much that is. So when we put it in miles, we can visualize 1.2 miles or 3 miles or 5 miles, but it's kind of hard to visualize 27,000 feet. The GPS system, says, stop in 500 feet or in 1,500 feet or in half a mile. So sometimes your units are kind of important there. So if I want to transform this into miles, I can set it up where I want to go on top, what I want to get rid of on bottom, right? So for every 1 mile, there's 5,280 feet. So if I take this number and multiply it by 1 divided by 5,280, or if I take the number and divide by 5,280, it's going to give me my answer in miles. So what is 27,630 divided by 5,280?
5.23.
5.23 miles. So, kind of what sounds more impressive, walking 27,000 feet or 5.23 miles. Some of you might say, oh, it's the exact same thing, but
So I literally just walked the whole time.
that's what his job is.
I'm sure he has nice benefits.
Maybe he gets a discount on his insurance because he has. And there's a lot of insurance companies that'll do that. They'll give you is it pedometer that measures how much you walk, and if you can show that you walk X amount or you do X amount, they can give you a discount on your insurance for that. So. Let's go to the homework real quick because sometimes various things pop up. This is 10-3. You are assigned 7 through 33 odd. So starting out, you're asked to identify each polygon and then find the sum of the measurements of the angles. 1, 2, 3, 4, 5, 6, 7, 8. It's probably the most common. Everyone knows how to identify. Right? Octagon, 8 sides, 4 sides. Now, 8, there's various different, correct answers here. You could say quadrilateral would be correct. I wouldn't necessarily assume it's a square because nothing's marked. Or assume any of the sides are parallel. So quadrilateral is kind of your safest bet. If it would draw in a 90 degrees, we would have a parallelogram because you don't know anything about the side lengths still. If they gave you the side lengths were all the same side lengths, you could say it was a square. Triangle, again, I wouldn't assume that it's an equilateral triangle, even though it looks equilateral. And I don't know if your book assumes it is equilateral and says equilateral triangle or if it just says triangle. 10, 1, 2, 3, 4, 5. It's a 5-sided shape. So it's not regular, but that's fine. The angle measurements are still going to sum up to that same formula, n minus 2 times 180. 10 and 11, same thing. 11, we have 1, 2, 3, 4, 5, 6, 7. 12, thanks. I have a 7-sided shape. So here, this angle and 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 this angle are going to add up to the same as n minus 2 times 180. Identify the quadrilaterals. They should really tell you 90 degrees, but you should be able to, if it looks 90, it is 90. starting 17 through 32, you're finding perimeter. So those are all pretty standard. On 21, you have to be careful. This is 10 yards, so this together would be 10 yards. So if you know this is 5, you know this is 5. All this together is 20 yards, so if you know this is 8, you know this is 12. Get red. You guys see that? So if I want perimeter, I would take 20 plus 5 plus 12 plus 5 plus 8 plus 10. Here's your regular shapes, the same thing. If this is 7 foot, this is 7 foot. If this is 10 feet, and this is 5, and this is 3, what is this? 2. Knowing this is 7, and this is 4, right? This would have to be 3. So this would have to be 4. I guess I wouldn't mean the 3. This is 4, so this is 4. So perimeter, I start at one point and walk around the whole shape and add up my total distance. Same thing here, everything's given. If they only give you one side, you're assuming it's regular, right? 27 is on the next page.
It's like that one.
Mm-hmm. So
I mean, I would understand that the other side would be.
I don't know
4
what
and the
this,
11.
okay.
It's actually one above it.
Yeah, I know. This is the 11.5 is this distance.
Yeah.
And this is 4.
So I know they would match on the other side, but how would you get the point for triangles? Are they equilateral?
Yeah, they're
sides?
equilaterals.
So
If
it's
they-
44.
Yeah. So this is also an equilateral too. So this is
6.5.
yeah, sorry. I don't know if mine's formatted a little different than yours. Sometimes it's kind of hard to read what goes with what. Yeah, this is 6.5. So this is going to be 6.5. This is 6.5. This is 6.5. 4, 5, 6, 7. Here, this is saying this is 3. It's saying all these are 3. All these are 2.75. But yeah, so you're just walking through that.
Do you count the insides as well?
No, because perimeter is only outside.
Oh, okay, okay.
So perimeter would just be if I walked around this shape.
That's,
We didn't go over dodecagon, things like that.
would that be 12?
Let's go back.
What was the isogon or whatever?
Oh, so that's a 20,
Oh,
and dodecagon is 12. Not a dodecagon, that's a 3-side, or that's a 3-dimensional shape. I guess that is dodecagon. You won't have to have those two memorized, but it is in your book, so you could look those up for your homework. The ones you'll need to expected are the ones I gave you on the PowerPoint. Any other questions? I think that's heptagon has a perimeter. 4 sides are the same length. The remaining sides are half as long. How long are the shorter sides? So that's setting you up kind of for an algebra problem. So heptagon has how many sides? Hep 7, right? And a 7. So I know the perimeter. So if I take 7 times, well, I know the perimeter is 110 feet. Right? 4 sides are the same length. So 4 times x, and the remaining sides are half as long. So 3 times, there's 3 sides, right? And they're half as long, and I can write that as x over 2. Where x is the side length, right? How long are the shorter sides? So here, since I want to know the shorter side lengths, I could write this as y over 2 and y, right? Y is the length of the shorter side. Sorry, that's not y over 2, it's 2y. 2y. If the remaining sides are half as long, then the original 4 sides are twice as long as the shorter side, right? 4 of them is twice as long as the shorter side, and there's 3 of them that are short. There's different ways to set it up. This is just one of them, and then you solve for y. You could solve for x and then divide by 2 to get y. So you get 10. But, you know, any of these are kind of free game. If it's not odd or not, it doesn't matter. Next time, we will cover section 4. And section 4 is area of polygons plus circles. So we'll do like pi r squared. And we'll also talk about the circumference of a circle. Circumference is perimeter. So I could say, well, maybe I want to enclose a swimming pool, a circular swimming pool with a fence. How much fence do I need to go around the swimming pool? Or I might want to know, how much grass do I need to buy to fill my backyard full of grass? So that'd be area. Basic figures, you can usually break them up into squares and rectangles and triangles. We'll do like of a football field or a track. We'll talk about the distance around it using a combination of perimeter for squares and perimeters for circles. And then we could talk about the area. And that will be 10-4. I'll see you guys on Friday, 33.
Yeah.
In this section.
Yeah, you might have.
Yeah.
Went over it. Maybe I wasn't.
Yeah. There's a couple different ways you can set it up.
Okay.
You want to know the shorter side, right?
Yeah. Mm-hmm.
So you can call that y.
Okay. Just
So-
set it up like an algebra problem.
Yeah, like an algebra problem. So here we have 110
Right.
equals,
Equals 4 sides.
there's 4 sides, oops. There's 4 sides that are twice as long as the shortest side, right?
The short side we're calling y.
And the short side we're calling y.
Okay.
So 2 times y would be the side length for 4 of them. And then for the 3 remaining sides, we don't know their length. We're just going to call that y.
So then it's algebra.
Yeah.
8y plus
Mhm.
3y.
Yes.
Equals 110.
Yes.
Combine like terms.
Divide.
11y divide by 110. Divide by 11. That's how it works.
So y is 10. So you can test yourself. Say 4 times 20 plus 3 times 10.
Why are you doing that now?
Well, this would be if I have 4 sides that are 20 lengths long and 3 sides that are 10, I get 110, which is just checking.
Oh, yeah.
My
you just
answer.
plugged in
Yeah.
for your y. Okay.
Yeah.
Makes sense.